Settle down. Don't look at me like that. What? What? There's no good staring at me. You've had all your treats for today. Yes, I have. Horrible little dog, are you? What? Nice. Right. Um. Okay. Another lazy day, really. I've been playing around with this salt formula. It turns out that the XZ compressed binaries are not in an archive of any description. So all the work I did creating an archive expansion component to my formula was a waste of time. It now comes down to binary, which is fairly straightforward, or binary compressed, which is a bit more complicated because, of course, what you've got to do is you've got to have a managed file with the name of the binary. You've got to download the compressed version and then decompress it to produce the binary. So the question is, do I want to really go through all of that when is it really worthwhile? It's probably just as well to download the binary. Now, the other thing, of course, is in the long run. See, at the moment, I'm downloading it from the download area of the Gitea.com website, so direct download. In the fullness of time, I would want to proxy that through my own artifact repository. So in actual fact, I'll be downloading it locally every time except for the first time. So I'm thinking I don't really care if it's a binary or a compressed binary. But for the purposes of the general purpose formula, maybe I do care. Oh, I don't know. I'll have a think about it. Anyway, so that was a lot of today. Well, I'll say a lot of today. I only did a couple of hours this morning because I'm lazy. Aren't I? Couldn't be bothered. I think I'm going to take a break in the near future and do some writing. And by break, I mean I'm not a break from doing these. What's the matter with you? You're in a very fussy mood today, aren't you? I'll take a break from doing this formula and do some writing because there's quite a lot of good stuff come up about Git recently on the forums. It's probably worth doing some time writing on that. So I've done a chapter on the details of the sort of Git plumbing side of the standard life cycle. I want to finish writing the porcelain version, mapping it back to the plumbing version. So you can see kind of like what the git add and git commands, git commit commands do in terms of the internals. Then I think the next thing to do is dealing with remotes, and that's sort of the next step. So that's how to get information from one repository to another. In other words, collaborating. And of course, The standard way of doing that nowadays is to use something like GitHub or GitLab. And the issue with that is it essentially turns a distributed version control system into a semi-central version control system. Back in the good old days, okay, you would have something like CVS or Subversion, and you as a developer would check that out, you would do your work, and then you would commit it back into the central repository. Now, Git, as it's used nowadays by the majority of people, is sort of a halfway house. Because you still have this idea of a central repository, but you've got also all the power of having a local repository. So it's kind of 50-50. In a truly distributed version control system, you don't have this central repository in the sense that, you know, you've got a GitHub or whatever. And so you can transfer your the commits in different and objects stored within different repositories within your organization can be freely exchanged, you know, if you so wish. And that's kind of where I want to go with it. I want to show the basic mechanics of here are two repositories, and here are different ways you can exchange information between them, you know, using email or directly. Then from that, you can say, okay, now that's kind of like the mechanics of it. And here is one way people do it, which is to use something like GitHub or a central repository. Oh, you're being fussy today. Do you mind? So yeah, so that's the next thing, and then we start getting into the gnarly details of branching, and the fact that branching is a useful abstraction for describing what you're doing, but it's not really what's going on, in the sense that within Git, branches are just, and tags for that matter, are just pointers. They're just references, literally, into a graph of changes. So I want to start with that. I want to start with the fact that we've got a graph of tree structures and commits, and then from that point out that whenever you talk about a branch in Git, all you're really talking about is a pointer to one of the nodes in that graph. And what we call a branch is just a sequence. Let me see if I can put this concisely. A sequence of commits where the ancestor chain points back to some point of divergence. It's harder to say than it is to actually show. But that's essentially all a branch is. And once you understand that, it becomes much easier to understand the mechanics of how branches. Oh, great, Kenny, that's really comfortable. How branches work, and it then becomes fairly obvious why certain merge strategies cause problems. Like, for example, doing a merge and then using an upstream commit to undo that merge or undo the effect of that merge. And why it is that when you then try to re-merge that merge, as far as Git's concerned, it already is in, and it will say there's nothing to be done. And that can be quite mysterious for people until you understand what the graph looks like. Once you understand what the graph looks like, it becomes apparent what the problem is. It also becomes apparent what the solution to that problem. So yeah, so that's the sort of next 2 or 3 chapters in my Git book. And on that note, we'll call it a night.